Gavin Gee here from UltimateReloader.com. I'm here at the 2020 SHOT Show with Bryan Litz himself. You got to know Bryan last year when I talked with him about Applied Ballistics, some of the research that he's doing, and the team that he has. This time we're going to talk about some developments in internal and external ballistics and kind of look to the future. Bryan, thank you very much.
Yeah, thanks for having
talking
me
with
again.
me. Yeah, so the capstone group is Berger, Lapua, Vidavuri, SK.
Yep.
And do you collaborate with all of those different teams?
Yeah, we're cooperative. We work together when we can, but everyone has, like, there's a company, like I work for Berger, that's my primary focus, but we leverage opportunities to cooperate wherever we can.
And your role with Berger is chief ballistician, is that correct?
Yes.
Okay. If I read your business card, that's what it would say.
Right.
That's got to be a pretty fun job.
Oh, it is, man. I have more fun than I should be allowed to have all the time. Testing bullets, designing bullets, looking for ways to improve bullets, going out and competing with bullets. It's my dream job for sure.
And it's a really good marriage of your business, which is Applied Ballistics. You do research, you do training, you have all sorts of resources. I have your books, Modern Advancements, and the ballistics fundamentals and all that, and still working my way through that material and applying it to my shooting. But so it's great to talk with you. Why don't we talk about, kind of looking back the last 10 years, or if we think about when Creedmoor came out, that was what, or 2007 somewhere. I guess that's a little bit more than 10 years.
Time flies.
It really does, yeah. And so we've seen these trends. Some of the cases that cartridges that are designed for longer, higher BC bullets, and bullet technology has evolved. BCs are getting more consistent. There's different technologies that people are incorporating into bullets. Tell me about kind of where you see the big leaps that have happened kind of in the last 10 years for internal and external ballistics.
Sure. So I'll start with external. That's where I'm most comfortable. And the big push in performance that I see in external ballistics is really tied to, like a lot of things that are manufactured, tied to the standards that we're able to achieve with machines, and that's always getting better. Car parts are getting more reliable due to better manufacturing processes, and it's elevating all the industries. And the way that's affecting the firearms industry, especially long-range precision shooting. Okay, the standard twist rates in barrels, were kind of set for the bullets that were available at that time. And if you wanted longer, higher BC bullets, well, they could have made those bullets then, but not as well as we can now. And the consequence, if they would have made those bullets then, the imbalance that's present in the bullets and the misalignment with which you can chamber a barrel, like just the slop in manufacturing between the gun and the bullets together, results in, bad precision, bad groups. And so they kind of standardized around stuff that they could make shoot well is a good balance of performance and the manufacturing capability of the time. And that's going way back, maybe early 1900s. But as we get into, this era of more precision manufacturing ability, that enables us to make more balanced bullets, better rifles, and we have the optics and everything to support more accurate long-range shooting. And so the consequence of that has been the steady migration of everything that supports higher performance. So starting with the bullet, bullets are getting longer and heavier for caliber than we've seen in the past. And to accommodate that, rifles need to have faster twist rate barrels to stabilize the bullets and have longer magazines. Okay, it's always this trade-off of I want to shoot this long nose high BC bullet, but it won't fit in my magazine. And so, it's changing a twist rate is not that hard. Changing a magazine length, that is more fundamental to the build of a gun, as you know. So, we're kind of coming up against the constraints for long-range precision in terms of what's built into the rifle. Now, if you're shooting a single-shot rifle or some setup where magazine length isn't a problem, or let's say you don't care about it, then you can enjoy all the precision that's out there. So for an example, I want to say 10 years ago now, I wrote an article called "What's Wrong with 30 Caliber?" Okay, 30 caliber has been a favorite for a long time, but my approach to it in pointing out the problem was that there's very few bullets that were heavy for caliber in 308. You know, 7mm we had 180s, 6.5 we had 140s. You know, those are heavy. You know, 6mm we had all the way up to 115s, and 90 grain 224s. Those bullet weights are all kind of on a trend line, and if you take that trend line to 308, that's 230 grains.
Yeah.
And at the time I wrote the article, there were almost no 30 caliber bullets from any manufacturer in that weight. Sierra had a 220 and a 240 Match King, and those were the only bullets in that class. Most of them were 190, 180, 185, 168. You know,
classic 168. Yep.
175s. And so, you know, that's what most people were shooting in 308. And when I looked at that as a ballistician, I'm like, I get it, everybody loves 30 caliber, but why aren't there proportionally heavy bullets in there? And fast forward 10 years, now think about how many bullets that we have from all manufacturers in the 230 grain weight range. Everything has been stepped up to accommodate that, the twist rates in the rifles. And so that's where I kind of see the advancement in external ballistic performance is with it started with better manufacturing that allowed us to go to these faster twist rates and shoot longer, heavier bullets without the dispersion you would get from sloppier manufacturing.
Yeah. An example of that, I recently built a 300 PRC. And as you know, that cartridge was designed to accommodate 225s, 250s, you know, the really heavy for caliber, long, high BC bullets. And, you know, that's I think one example of the evolution. Going back to what you're saying about the twist rates, you know, the classic 22 250, that would have been what, 1 in 12 maybe for 55 grain bullets. And then now we've got Valkyrie where you're at 1 in 7 and you're talking about 95 grain bullets. And the cartridge optimized for the internal ballistics efficiency. And
you bring up a good point about varmint cartridges that reminds me of another sort of advancement in the sense that, so varmint cartridges, 220 Swift, you know, the legendary varmint cartridges, used to be defined by how flat of a trajectory they could make. You know, like you can hold right on a groundhog out to 300 yards and you're going to be on them. You know, super high velocity with lightweight bullets. Well, the thing that was a reality during the time that those cartridges were developed for varmint hunting was that range finding was a problem. You know, laser rangefinders were not as proliferant as they are now. You know, you couldn't get one. You know, I hunted varmints a lot in high school, and a laser rangefinder was out of my reach.
Right.
And so,
if only you could imagine forward to the equipment you have nowadays.
Oh, geez.
Your mobile lab, your Doppler radar.
So, whenever range is an uncertainty, there's great value in a flat trajectory. So those cartridges were made to absorb all that range uncertainty with the flat trajectory. Well, now that laser rangefinders are a dime a dozen, you can get them easily. The range uncertainty is no longer the thing that's driving your hit percentage. It's windage now. So what are we seeing now are heavier, higher BC bullets in faster twist barrels. Yeah, they're slower in muzzle velocity, so they're not as flat across short range. But that's not important anymore because we don't have the range uncertainty that we used to deal with. And so as that laser rangefinding technology became more available to all shooters, hunters of all disciplines, the value of a flat trajectory kind of went away as far as like what drives hit percentage. And now, you know, things look different as far as what's optimal. Because you're trying to minimize what is now your biggest uncertainty, which is wind.
So let's go back 10 years. I think there's two things I'm thinking about that have also changed. One is the public interest in ballistics. You know, you go back 10 to 15 years ago, how many people had ballistic calculator technology available and that sort of thing. Obviously people are always faster, stronger, lighter, you know, with guns. I want to be more precision oriented, I want to be more long range oriented. So I think there's been and then, you know, there's PRS, all these disciplines and stuff like that. Now ELR. But then also the tools to match those capabilities. I know for me, I've recently started working with Adam McDonald's shot marker. So now I have at 1,000 yards an E-target that'll give me 1 to 2 millimeter resolution on shot placement, and it'll give me velocity and SD. Now I can reverse engineer if I know my atmospheric's good enough. You know, is my BC correct? Is it consistent? And this is my new playground, right? I'm still learning all this, but for the content that I generate and for my process of validating dope for competition, it's been an absolute game changer. And that's just one data point, right? I don't have the Doppler to see the bullet all the way down range, but that's an $800 tool.
Yeah, yeah, you're right. The electronics,
It's crazy.
The electronics, it's like they grow on trees. They're so cheap, you know. And then once they're productized into something that's valuable, that gives us good information, then it's amazing what we can do. Speaking of measuring performance downrange, you know, the evolution that we've gone through just in the last couple of years. You know, we used to determine all of our BCs with acoustics, you know, and do it at different distances to try to get a few data points. And we assessed ballistic coefficients for Berger Bullets that way, and for all of the bullets in the Applied Ballistics library, so that you could access them on whatever ballistic solver you're using. And you know, we integrate these ballistic solvers into a number of different things, like the Kestrel, Bushnell rangefinder, the Garmin, and so you have the same solver. That used to be a big problem. Every solver was different. All the BCs were, you didn't really know if they were accurate. So you could have quite a lot of disparity in a ballistic solution depending on where you got your solver and your data. But now we're kind of standardizing the solver side of it. They're the equations of motion. There's no reason they should be different from one device to another. So we're kind of standardizing those integrations, and the data collection is now what we're focused on. And the data collection, we've gone from the acoustic way of gathering it and having a static library to now we've got the Doppler radar, and we're testing things much more extensively and learning a lot more. Shot-to-shot BC variation being one really enlightening thing that we're getting onto, which is an important factor of understanding these long, heavy for caliber bullets, because that's normally the ones that have this shot-to-shot variation problem.
And when you had your acoustic sensors, did that require supersonic so that you could have the crack to measure?
Not really, because you can clamp a microphone to a board and shoot the board, and that gives it a signal for time of flight.
I see. So it's not just looking at the shock wave passing by then.
Right. It doesn't. It can work with an impact target.
Gotcha. Okay.
So, you know, we went also in the way that we assess performance of a bullet. Years ago, it was just, if you said BC, G1 was the only one that there was. And, you know, we kind of got away from that a little bit for long-range bullets, and determined that the G7 BC is a much better representation over a wide velocity range. And so we moved to G7 to assess performance of a lot of the long-range bullets. But that still leaves some imperfection due to the mismatch of long-range bullets to the G7 standard. It's a big improvement over G1, but it's still not quite there.
The G1 is like a Volvo, right? Aerodynamically, you're comparing that to a Ferrari. It's not a very linear type of a thing. The G7 is at least a boat tail, and it's representative. You know, are there other models that you're looking at now then?
Well, not really, because we've really transcended the ballistic coefficient model of ballistic performance assessment, because we don't have to try to match a standard, because with the Doppler radar, it measures the actual drag of every bullet that we shoot.
Gotcha.
So there's no need to compromise your drag assessment in any way by comparing it to a standard. When we shoot, you know, 10 rounds and we have 10 radar tracks that overlay, there's no reason why not to take that data directly and put it into the solver, so that shooters are modeling trajectories based on the actual drag of the bullet. That's the most direct and accurate way of doing it.
Question for you on that then. You have a sophisticated knowledge of ballistics, obviously, and the G1 and the G7 BCs are the numbers that they put on the boxes, and people understand that because it's a number. If you're looking at actual Doppler radar and plugging that into a solver, how do you communicate that in a standardized way to compare one bullet to another?
That's a really good question, and I think that's why BCs can never really go away. You know, they're inferior, they're technically inferior for assessing ballistic trajectories if you have custom drag models, but they'll always have value in that easy glance, oh, this bullet is this class of performance, and it's contained in one number. Because
compared to a Volvo, this bullet is quite good.
Right.
Good, but not great.
Or you know, comparing my Camaro to your Mustang, you know, whatever it is. But the BC is always going to have value, and it's still, you can still calculate a reasonably accurate trajectory with BCs. It's just not the best way to do it for long range. The problem with the CDMs, the custom drag models, is that they're represented by a whole table of numbers. You know, and that's not something that's easily communicated.
Sure.
But if it's running behind the scenes in your ballistic solver, then that's the best you can do. So speaking of advancements, we went from using BCs that are in print, so they're pretty static, to getting them into an online database. So whenever we do tests with our Doppler radar, we upload those results to a database online, and then anybody that has an Applied Ballistics device that's connected with an app gets a notification that there's new data in the library, and they can pull that down and have access to data that we just shot that day.
Wow.
So the update rate, the way that we're able to put data out to our users is incredibly enhanced now. And that's, that was about as far as we could go until we decided to put our Doppler radar in a mobile laboratory and travel it to events.
Wow.
Because even with custom drag models, let's say you're going to shoot a match tomorrow with a 140 grain hybrid, and you pull down the CDM for that, and you said, well, this is the best model for my gun, but what if you're shooting a different lot of bullets? What if you have a different twist rate? What if you have a high round count on your barrel?
Yeah.
There are potentially things about your rifle that are different from the rifle we tested the bullet in, and there's a question of how different our representation can be from you.
Yeah.
So with the mobile lab, we bring it to the event. You come in the day before the match, shoot on the radar, get a personal drag model for your rifle, and that information is uploaded into the library so that that night before the match, you can pull it down into your device, build a gun, and go into the match with Doppler radar that was just shot the day before the match. That it doesn't get any more closed loop than that.
Wow. So again, we're looking forward now. We're kind of looking forward. What in the next 10 years, kind of where do you see things going, both in the research that you're doing? I know that we could talk probably for days about that, but at a high level, and then also for the kinds of capabilities that your average shooter or PRS competitor, that class of shooter is going to have available to them.
We're seeing a lot more integration of electro-optics. The SIG BDX, where you've got a disturbed reticle, you've got information made available to you through your optic electronically. Weapon-mounted laser rangefinders, I think, are something we're going to see more of as they become less expensive. Wind reading, I think, standoff anemometers or laser wind readers. That technology has been maturing for a long time, and it works to some degree, but I think at some point it's going to, whatever economic situation needs to occur for it to be viable for commercial market is going to happen, and we're going to have that technology available.
That's a big one.
I think a lot of the advancements are going to involve electronics, but the thing I would like to emphasize, as this trend of electronics getting into shooting, with ballistic solvers, I mean, it used to be ballistic solvers either weren't available or weren't trusted, and guys would have to shoot their gun every 100 yards and keep a logbook, and there was no electronics involved. But the one advantage of doing it that way is shooters were very accountable to their shooting, to their marksmanship fundamentals when that was the case. You had to shoot every yard line, so you had to set up and tear down every 100 yards, and you became very practiced and very used to doing that and very good at it. Well, these days with the ballistic solvers, it's almost like, younger people have a more digital mindset and a more like electronics will solve my problem. So I have this fire solution that I know is accurate to 1,200 meters, so there's no reason I shouldn't be able to hit anything out to 1,200 meters. Well, you still have to shoot the gun. You still have to pull the trigger straight to the rear without moving the sights off the target. And that's not to be taken for granted. That's a skill that you got to practice all the time. So the word of caution here is, as all these advancements in electronics and technology come out to assist us as tools, shooters, I cannot lose sight of the value of practice. And don't forget, this is an art. This is a physical activity that requires muscle memory and practice and skill. So don't become too much reliant on the technology and use it as a crutch.
I think of the kids that are learning to drive for the first time, and they have phones with navigation, and what happens when your battery dies. You have no which way is north, south, east, west. And to me in shooting, part of the satisfaction is keeping my hands on the knobs and levers, right? That's why I like to run manual machinery and build rifles. I'm a manual transmission kind of guy. But then when you see some cool new technology, the Tesla or whatever it is, that's equally interesting. But to me, yeah, I like the idea of the skill of the shooter.
Mm-hmm.
That's really compelling to me.
There's more better advanced tools coming out, but the best tool that we're always going to have is right here.
Absolutely. Well, this certainly makes me look forward to the future. Electronic laser wind reading technology, better ballistics, further distances. I'm hoping to do more ELR oriented stuff this year. It's not really something I've tapped into, and maybe build a rifle, and that'll incorporate a lot of elements that are new to me, and that's what it's always about for me, is what's that next challenge to take on. And in the shooting sports world, there's always something.
Oh, there's always something. Just think of the nature of distance, there's always a further distance to go for once you've mastered things at one distance. You can always make targets smaller.
Yep.
There's just no end to it.
Yeah, absolutely. And if people want to know more about your research and to learn from you, what are the best resources from Applied Ballistics?
The most current stuff, you can follow us on Facebook. We post about the testing that we're doing once in a while. Once testing has been completed and written up, we'll eventually roll that out into books. So we have a number of books and DVDs that you can get to see what we've been up to. And you can get those on our website or through Amazon, Midway, anywhere you'd expect to get shooting books. And of course by subscribing to your channel.
And then, are you doing seminars this year?
Yep, seminars. We were too busy to do one this past fall, but we're looking to get back into that spring-fall cycle of seminars. Don't know where and when it will be yet on the venue, but the plan is to hold a spring seminar in a fall this year.
Awesome. Well, Bryan, thank you very much for talking with me.
Sure, thank you.
I hope you all have enjoyed this discussion. If you have some questions or want to discuss what we've been talking about, please drop a comment. Don't forget to subscribe with notifications, because I've got a lot more SHOT Show 2020 content. I'm going to be incorporating some of the knowledge from Bryan into the rifles I'm building and the shooting that I'm doing, and that I hope that you enjoy that. And I'm really looking forward to advancing what I'm doing and learning with you all. So until next time, happy shooting and happy reloading.